I've pulled all of the transistors out of the heatsink back here, you can see, and we're going to test them. And I'm going to go over with you the way to test them using just a plain old meter. We're first going to use the analog meter, then we're going to use the digital meter. It really doesn't matter. I like the analog meter. I don't know why. I guess it's because I've done it for so long. But first you have to kind of understand what a transistor is all about. Whenever you measure a transistor, it will measure like two diodes that are connected together. So in the case of an NPN transistor, it would be like there are two diodes that are connected with the anodes connected in the center and the cathodes on either end. See that? So this would represent like an NPN transistor. Now don't mistake these two diodes as a transistor. This would not work like a transistor because the junction between these two anodes would have to have a special semiconductive junction for it to act as a base. So this is just going to act like two diodes that are reversed from one another. But for your meter, it'll test like this circuit. And with the PNP, it's just the opposite polarity. So if you take the cathodes and you tie them together in the center, and then the anodes are on the outside, you would have a PNP transistor. So let's test that. So for the NPN transistor, if I take my red probe and I measure at that junction point and I go on either side, I won't get a reading because it's actually blocking. If I take the black probe and I put it in the middle, and remember, this junction would act like your base, okay? So the base, collector, emitter, or collector, emitter, really doesn't matter. And if I put the black probe in the middle on the NPN, I get a reading in both directions. See that? And then, of course, since these two diodes are reversed of one another, I won't get any reading either way, right? I won't get any reading either way, like that. And a PNP is just going to be the opposite. When I put the black probe in the middle like I did on the NPN, I don't get anything. But when I put the red probe on the base, or in the middle of this junction, I get a reading in both directions. And again, no reading on the outsides. So if that's the case, this is NPN, this is PNP. Let's look at this transistor. This is an MJ15022, which I think is an NPN. If that's the case, this transistor, if it's good, I should be able to put the black probe on the base. So on a TO3 case transistor, this is a TO3 type package. If you're looking at the bottom of it, you have a short distance from this screw hole to the pins, and then you have a longer distance from this screw hole to the pins. See how they're offset? If you hold it this way, like almost like a person standing, right? So here's their head and then their torso and their feet. The base is always on the left, the emitter is always on the right, and the collector is the metal case of the transistor itself. And this doesn't matter if it's NPN or PNP, the base is always this pin on the left, and the emitter is always this pin on the right, and the collector is always this case. So if we hold it that way, if I take the black probe, remember this is NPN, I put it on the base, I go base to collector, and you can see I get a reading of 500 ohms because I'm on times 100. And I go base to emitter, I get about 500 ohms. If I reverse it and I put the red probe on the base to collector, nothing. Base to emitter, nothing. And then emitter collector, either way, nothing. This is a good transistor, at least from what we can statically test. So that's how you test it. Now if it was PNP, it would be exactly the same, except you'd put the red probe on the base and get the readings. All right, let's grab another one. This is MJ15022. And so it's an NPN, so I want the black probe on the base. and I get a reading that way and a reading that way. But did you notice something? When I went from the base to the collector, it went all the way to 0. That's a dead short. In other words, I'm not reading a forward voltage drop of a diode, I'm reading a short. This is what it should look like. So the base to emitter is good. That's not. And if I reverse the probes, I bet you, look at that. It reads a short in both directions. This is a bad transistor. It's shorted. Let's grab the next one. This one, MJ15023, so this is a PNP. So we want to put the red probe on the base. If we measure, base to collector is good. Base to emitter is good. And then, emitter collector is reading in both directions as a dead short. This is a bad transistor. This has an emitter collector short. This one has a collector to base short. So these are both shorted. They're both bad. Let's check this one. Those are both out of the same channel as well. So let's pull this one. This is NPN. So we're going to put the black probe here. Dead short. We don't even need to go any further. That one's bad. 3 out of 6 so far on this channel. There's 6 transistors on each channel. 3 NPN, 3 PNP. All right, this is another NPN. So we're going to go here. Wow, that one's shorted. Wow, that one's shorted like everywhere. All 3 pins are shorted. Look, everything's shorted every direction. That one's really shorted. 4 out of 6 bad. What's this one? This one is a PNP, right? MJ15023, so we'll move our probes, the red on the base. Dead short. Dead short. Dead short. It's shorted. And this one is the last, this is another PNP. Wow. All 6 transistors on that channel are bad. They're shot. Now, this other one here was out of the other channel and it was good. And I tested them. That's why they're over there. And they all tested good. Let's use a regular digital meter. You put it on diode check. See this little diode symbol? Like that. And same thing. So this is my good NPN off of the other channel that we tested first. You hear the little blip? So with an NPN transistor on a digital meter in diode check mode, it's the opposite. So on an NPN transistor, you put the red probe on the base and it'll read both ways. And then when you flip it around, you get nothing. And then when we read from emitter to base, or emitter collector, you read nothing. So the colors of the probes are opposite on these, because this is reading the actual forward voltage drop of the diode in the one direction, whereas this is not. It's actually reading resistance. So it's kind of a different setup. So anyway, this is a good transistor. So you can see that the 2 meters do the same thing. The only difference is whether it's the red or the black probe is on the base. Depends on if you're digital meter or your analog meter. Doesn't matter, don't worry about it. So all of the transistors on the one channel tested good. And all the other transistors on this channel tested bad, shorted. And that's it. One last thing we'll do here, let's grab this thing. I just want to show you, this is a bad NPN. This is the one that tested shorted with our meter. Short circuit on red and green, remember? And you can see red is the base, green is the collector. This is the one that had the bad collector to base short. And if I connect our little tester to the good transistor, right? I'm just hooking these probes up in any old direction. Doesn't matter with these things, they don't care. They figure out the pin out themselves. And there you go. It tests good. NPN. And it shows you the base, emitter, and collector. You can see the current gain and so forth. So there's 3 different methods to test a transistor. I can just buzz through them with this much faster than I can connect those 3 probes to that little tester thingy and wait for it to do its little testing thing, so that's why I like this. I also like to watch the needle swing. I like to watch the actual resistance, although watching the actual forward voltage drop on the digital meter is also just as good. So either one is good, whichever one you're comfortable with, whichever one you get used to, and whichever meter you have. Maybe you don't have a a good digital meter, or maybe you don't have an analog meter. So there's both techniques. But long and short of it is, we need a bunch of transistors, don't we? Okay, we have all the transistors replaced, and what I ended up going with was the MJ21193 and MJ21194 complementary pair. What was originally in there was MJ15022 and MJ15024, I believe. Or no, I'm sorry, 15023. So they're very similar, almost identical. Yeah, 15022 and 15023. They're almost identical. The only difference really is the cutoff voltage, which is, these are actually a little bit better. This is, I think these are just a newer transistor than those other ones as far as when they actually came out. But anyway, they're for this circuit's all intents and purposes, they're identical. I did replace both sides. Why did I do that? Well, first of all, because they are different families of transistors, although like I said they're almost identical. It probably wouldn't make a difference, but if we're going to replace one set, we don't know what the other side went through, so we're going to replace them as well. The owner wants that. He doesn't want to have to come back and deal with something later. So whole new set of transistors. We're ready to test it.